Hello guys, good morning. You are welcome to my YouTube channel, the Explicit Tutorials. As you all know, my name is Mr. Joseph or Mr. Explicit. Please, as you watch this video, do subscribe so that when I upload a new content, you'll be notified by YouTube, alright? Before we jump into today's business, please and please, those of you downloading my videos without watching them, it is not actually proper. I know I'm not the one subscribing for you, all right, but at least reason with me, more reason out together, you understand? Because if you keep downloading my videos without watching them, you are not contributing positively to my channel, and it is disturbing me, all right? It is getting me worried because sometimes even when I'm not chanced, upon the request of a student to upload or to do a video on a topic, I don't mind it's just one student. I make sure I do it. Alright, please, I'm begging us. I beg now. Reason now with more that is reason more that is more reason now together. Reason with me. Just more your reason now together. You see, if you don't watch my videos without if you don't watch my videos and you are downloading them, it's yeah now. The reason now. So please and please, I beg you with my father's shoe, as you are watching this video, please, yes, just be watching it. Just the watch am, just the watch am. If I don't download, at least if you want to download, watch it at least just once, one like this. I know that sometimes some of my videos are long because I don't want to do them segmentally, because there are some topics I want to treat by segmenting the topics. It will affect the viewers. All right, there are some topics that when you treat, you don't take it at once. This they may not follow up again because of the complexity of the topic. All right, like the topic I treated yesterday called reflection. This video is a continuation of that one. All right, that yes, the topic was reflection at plane and curved surface. I could not just take it. I could not just take half of that topic. All right, I have to take it. I have to take the full topic. I'll know that anything that is based on non-calculation, it can be trashed. All right, the student can actually justice to it. But this video, this very one, is based on just calculations. All right, did you see how I did it? So please and please, watch before you download. Please. If you keep downloading my videos without watching them, then it means you are not helping your brother. I know I'm your brother in the Lord. Okay, and exactly another one. If you know that you do enjoy my videos have transformed, or my videos have transformed your life into the permanent word site. Don't keep it to yourself. Share it to people. Tell people about the good news. Tell the people how physics, chemistry, biology, and mathematics are now so easy peasy. Alright, it's good now. We'll help ourselves like that. You know that kind of thing now. Alright, so let's go into this business. Thanks for understanding. Please, I beg, watch before you download it. I know. Yes, yeah. Okay, an object placed 50 centimeter away from the focus. This question is not complete, so I have to include mine. An object placed 50 centimeter away from the focus of an emerging lens of focal length 15 centimeter produces a focused image on a screen. If the image is focused on the screen, what does that tell you? It means that the image is what? Real and not virtual. Alright, because a virtual image is that image that cannot be focused on the screen and it does not allow the passage of what? Light. But real image is produced by spherical mirrors and it is focused on the screen. It also allows the passage of what? Light. Okay, now calculate the distance between the object and the screen. Calculate the distance between the object and the screen. All right, so let's take this as a plane surface. I'll place here my objects. I will assume here as my objects, and this very John as my what? Screen, as my screen, and that is where the image is focused. And of course, you know we have lens. Don't forget that, very important. Now they said that the object is placed 50 centimeter. Please, they said the focal length is 15, and I told that the focal length of a mirror, of a lens, is the distance between the center of curvature and the principal focus. Right? The center of curvature means that point in which light can pass through, thereby dividing the mirrors into sections. And I said that vertex is it is a middle part. All right, it is the middle part of the surface of what the mirror. That is a vertex. All right, take note of that. The said the focal length is what 15. So the distance from this region, you have 50 centimeters, and don't forget you have f, and it's what 15 centimeters. 15 centimeters. All right. So which means that in total, from here to here, 50 plus 15, I have 65 centimeters, all right? But they are saying now that we should calculate the distance from the objects to the screen. The distance between the objects and the screen. So which means from here to here, I'll make it what? X. But before I will calculate for the distance between this objects and the screen, I will also have to calculate the distance from the lens to the screen. I'll make it what? X. Alright, so from what we have done so far, it means that our U therefore becomes what? 65 centimeters, and our F of course is what? 15 centimeters. So let's get started. I gave us that V is equals UF over U minus F. U is 65 and F is 15. U is 65 minus what? 15. This times this, I'll get 975 over this minus this, I'll get what? 50. I'll get what? 50, right? I'll get 50. It therefore means that V is equals 975 divided by 50 is what? 19.5 centimeters. Alright, so which means that from here to here is now what? 19.5 centimeters. However, to now calculate the distance from the object to the screen, what does that tell you? It means it is the distance here plus the distance here. It therefore means that to calculate distance from this place becomes 65 plus 19.5. I'll get what? 84.5, which is approximately 85 centimeters. Alright, hope it's clear enough. Don't you see how easy it is? So the answer is what? 85 centimeters. Alright, take note that the image is real. Okay? It is a real image since it was focused on the screen. Look at the word there. It was focused on the screen. Alright, that is for that. That is number one. Number two, an object 40 centimeters from a converging lens of focal length 20, which means that my F is 20 centimeters. Of course, the U is what? 40 centimeters. It said moves with a velocity of 5 centimeters per second towards the lens. Calculate the image position after 2 seconds. Please, this question is quite confusing. To now calculate the total image, object distance, please, it said it moved towards the lens with a velocity of what? 5 centimeters per second. Simply do it as 2 times 5. I'll have what? 10, right? Which means that it becomes 40 minus 10. I'll have what? 30 centimeters. So which means that my U therefore becomes what? 30 centimeters. So solving, you have V equals UF over U minus F. U is 30. What is my focal length? 20 over 30 minus 20. I'll have 600 over what? 10. Because this time this is 600 and this minus this is what? 10. This will go into this. And now that V is equals what? 60 centimeters. So the answer is what? 60 centimeters. Alright. So we are done with these two questions on the board. So let's look at the ones we have on the textbook. Alright. We have question 1 to 10 on the textbook. Alright. If time permits, I can solve the first 5 questions and do In our next video, we'll do justice to the last 5. And if time permits, we can solve more questions. All right. Since we are done with this, because of space, I'll rub it up, please. Because of space. All right. So we have enough space now. The first one says, describe the image of a candle flame located 40 centimeters from a concave spherical mirror. I told you that concave, there is radius of curvature and the focal length of concave mirror are positive. All right, but in concave lens, they are negative. As for convex mirror, the radius of curvature and focal length are negative. Then in convex lens, they are what? Positive. All right, don't worry. When I'm taking lens, you understand it better. Okay. So it said, describe the image of a candle flame located 40 centimeters. So which means that my U is what? 40 centimeters. All right. From a concave spherical mirror of radius 64 centimeters. That is radius 64 centimeters. We'll be given radius, which is called what? Radius of curvature. Radius of what? Curvature. Radius of what? Curvature. Now. I told us in our previous class that the radius of curvature of a mirror is twice the focal length, right? I think we did that. It's twice the focal length. Radius of curvature is 64. Then you have 2f, divide both sides by 2. F is equals what? 32 centimeters. 32 centimeters. Don't forget our formula. V equals UF over U minus what? F. V is equals U is 40 minus 32. Okay, sorry. Times 32. Then 40 minus 32. I'll have, then 40 times 32. 40 times 32. I'll have 1280 divided by 8. Divided by 8, I'll have V becomes what? 160. All right. For my velocity, sorry, I said my velocity. For the image object, for the image distance, to be positive, it means that the image is what? Real. It means that the image is what? Real. It means that the image is what? Real. Okay. And the next one is to calculate for the magnification. I told us mirror magnification is given as what? That is minus image distance over what? Object distance. But the magnification of lenses, the total magnification of lenses is equals the product of the magnification of the respective what? Lenses. All right. So this one is for lens, but this one is for what? Mirror. Okay. Take note of that. So magnification is equals minus, I got my V to be what? 60. So it becomes minus 160. Minus 160 over what? U is 40 over what? 40. So this will go into this. Magnification is equals what? Minus 4 centimeters. Minus 4 centimeters. All right. It therefore means that the image is what? Inverted. And what? Magnified. All right. Therefore, the image is real. Inverted at what? That is upside down. Inverted at what? Magnified. So that is the final answer. The number 2 is a rod 10 that is 10 meter long is placed along the principal axis. So which means that in the first case, U is what? 10 meters. Is placed along the principal axis of a convex mirror of focal length 4 cm. I told us that in a convex lens, radius of curvature and focal length are what? Negative. So they gave us f to be 4, so it means minus what? 4 centimeters. For it to be given as 4, it means that it's going to be what? Minus 4 centimeters, negative. If the side nearer the mirror is 6 centimeters, this is another instance of view, which is what? 6 centimeters. Find the length of the image. Now this question is from change in image distance equals VA minus what? VB. Change in image distance equals VA minus what? VB. In doing that, don't forget that we have that V equals U1 F1 over U1 minus what? F1. Alright, that's VA now. We are calculating for VA. U is what? 10 times minus 4. Don't forget it's negative. Over 10 minus what? 4. Alright, 10 minus 4. This is the minus, but the F was having minus 4, right? The F was minus 4. So, okay, is it 10? Okay, sorry. You're having 6, sorry, 6. 6. Alright, you have, this time this is what? Minus 24 centimeters over what? You have plus, minus times minus is what? Plus, right? So this plus this, you have what? 10. Which means that VA is equals minus 2.4 centimeters. Minus 2.4 centimeters. Now to calculate for VB, it is the addition of this one and this one, which means I'll have what? 16 centimeters. So my U, it becomes U2, that is 16 centimeter times minus 4 over 16 minus what? 4. Alright, minus 4. So 16 times 4 now. 16 times 4, I'll have minus 64 over. So minus times, that is minus times minus is plus. So this time this is what? 20. So 64 divided by 20, I'll have 3.2. However, there's minus, that is minus 3.2. Therefore, the final answer becomes change in image distance equals minus 2.4, that is minus, open bracket, minus 3.2. So change in image distance equals minus 2.4, minus times minus is plus, then 33.2. So minus 2.4 plus 3.2, I'll have what? Change in image distance is equals what? 0.8 centimeters. What did they get as a value? 8. Okay, in meters, fine. Meters. Alright. Okay, that is what we have the answer to be. So, number 3, the question very easy. Just take it bit by bit. You understand it, okay? So, number 3, the ministry is progressing. Now, number 3, it said an object 7 centimeter high is placed 15. An object 7 centimeter high is placed 50 centimeters from a convex spherical mirror of radius 45 centimeters. So convex, that means that F again is what? Minus 45 centimeters. Describe its image and give the value of the image distance and magnification. So which means that our U is what? 15 centimeters. 15 centimeters. Don't forget that we said that arrow is equals 2F So r, that is r now. Oh, was radius of curvature given just now? Radius of curvature, sorry, this is what we are given. Radius is minus this. Yeah, it's not f, minus. Okay, so radius is what? Minus 45 equals 2f, divide both sides by 2, which means that f is equals 45. 45 divided by 2, I'll have minus 2.5 centimeters. Minus 2.5 centimeters. Don't forget that v is equals uf over u minus f. U is what? 15 times minus 22.5 over 15 minus 22.5. Alright? Which means that v is equals 22.5 times 15 equals 337.5. Don't forget minus over minus times minus is plus, right? So which means that 22.5 plus 15 equals 37.45. So let's divide. So 337.5 divided by 37.5 equals minus what? 9 centimeters. Now for it to be minus 9 centimeters, it means that the image is what? Virtual. The image is virtual and what? Inverted, alright? It is virtual and what? Inverted, alright? Take note of that. It is very important. Now, okay, the same we are to have, okay, we are expected to also calculate for what? The magnification. Good. So magnification is what? Minus v over u. Yes. V, we've gotten v as what? Minus 9. Then u as what? U is what? 15. U is 15. So which means that I have okay, I have this. Okay, sorry. So we have minus v, right? Then minus 9. I was wondering, not this sign of 18, they can put somebody into trouble. So which means that minus times minus is plus, right? Which means that 9 divided by 15. 9 divided by 15, I'll have 0.6 centimeters. So the answer is magnification. Yeah, the answer is what? 0. Alright, so please take note of that. Take note of that. It means we got magnification at 0.6 and the image is now as what? Minus 9. Alright, so number 4, let's take number 4. Number 4 says, what is the focal length of a convex spherical mirror which produces an image 1/6 the size of an object located? Okay, which means that u is 12. Let's check your textbook. We are calculating for question 4. Question 4, okay? U is 12 centimeters, or let me read it out. What is the focal length of a convex spherical mirror? So which means that we are asking for the focal length, and the answer must be negative, since it's what? A convex mirror, which produces an image 1/6. 1/6, the image connote what? The 1/6 that was produced connote what? Magnification. Take note of that. Located 12 centimeter as written on the board. Okay, so what do we do next? Magnification we know is minus v over what? U. Alright, magnification is what? 1/6 minus v over u. So this times this is u. Okay? 12, sorry. So this times this is 12. then minus 6v. Divide both sides by 6. And we have that v is equals what? Minus 2. Okay, they said the focal length, alright? So, for now, we got the v as what? Minus 2. Is that not correct? Okay. Okay, now to not calculate for the focal length is equals what? uv over u plus v. To calculate for focal length, we use uv over what? U plus what? V. So focal length now, focal length becomes u is what? 12 times minus what? 2 over u is 12 plus minus what? 2. So focal length is equals minus 24 over plus times minus, alright? So 12 minus 2, I have what? 10. So focal length is equals 24 divided by 10 equals minus 2.4 centimeters. Yes, it must be minus. If you should have your focal length as positive when it is convex mirror, you are very wrong. Alright, so at this point we'll call it a day. In our next class we shall be solving question 5 to 10. Alright, question 5 to 10. If you know you actually learned something in this video, please forward the video to your friends who are also in need of it. Do have a wonderful day.